Hello everybody, it's Grant, your friendly neighborhood InstructLab community member. Today we got something fantastic planned for you. It is Tuesday, September 3rd, 3:50 p.m. Just finished all my meetings and I thought, let's create a video showing the new InstructLab version 0.18.3 on enterprise class hardware. What do I mean by enterprise? So I got a box spun up. It's got four NVIDIA L4s, I believe, maybe L40s. And so we're going to get InstructLab set up. I'm going to show you how to install the CUDA drivers, all of that stuff. I am using RHEL 9.4, so it should be an exciting afternoon for us. And I will put all of the commands in the description of the video so you can replicate this on your own RHEL 9.4 box. So let's get started. Let's go over to the terminal. First, let's take a quick peek at NV Top here and see what we got. We do have 4 NVIDIA L4 cards. All right, so that's good. How much system memory do we have? Each of these cards looks like 22 gigs of memory. Let's do a sudo dnf install htop real quick so we can look at the processors and take a look at the amount of memory that we have. Looks like we have 48 processors and 181 gigs of memory. Not too shabby. Not too shabby. All right, so let's get started. First thing I want to do is install the NVIDIA or the CUDA toolkit. So I'm just going to sudo dnf install CUDA-toolkit, and then we want 12.4. So let's get that installed, and you can see this is 7.5 gigs or something. So if it begins to get slow, I'll fast forward through that parts. If I failed to mention, this is a Red Hat Enterprise Linux 9.4 box, and I am using the upstream InstructLab version 0.18.3. That's what we're going to be doing today. I don't have the InstructLab installed yet. So we're going to install all the drivers, software stack. Then we're going to install InstructLab, play around with a little bit. I'll show you some training. We'll use the Back to the Future stuff. We'll take a look at a custom profile for these L4 cards since I'm running 4 of them. And we'll just have some fun. Okay, that worked. Let's make this a little bit bigger here so we can see. Down here in this bottom left, I'm going to start at H-top, and over here on the right, I'm going to do an NV top, just so we can see things as we're going along here. Now, I did have a previous version of CUDA on this box, which was 12.6, so I uninstalled that and downgraded to 12.4, but because of that, I think I have a CUDA directory here that I want to remove. Okay, you may not have to do that on your box, or you definitely won't if you didn't have 12.6 installed first. And then I'm just going to create a symlink to my current CUDA directory, which should be 12.4, and I'm going to link that to CUDA. You can see here the remnants of that CUDA 12.6. InstructLab actually needs CUDA 12.4. All right, so we got all that set up. Next, we want to install some additional packages. And I am going to paste this in so you can see the packages we're going to install. And then I'm also going to go to full screen so you can see a little bit better here. We're going to install libcudadnn8, the develop packages, and a few other packages. Again, I will put these package names in the description. So if you're on a RHEL 9.4 box, you can just copy and paste it. Looks like we're going to be at another 1.5 gigs here. The CUDA stuff is just... man, you gotta have some disk space and some fast bandwidth to get started with this stuff. But you can see the GPUs, the memory, all that's looking good right now. We're actually installing it. And this is going to install some of the needed libraries for things like vllm, which we're going to install a little bit later today. We're going to be using that for our inferencing engine or server. Okay, The next thing I want to do, and I found this out via trial and error, this one of these packages has a library that we need, but it puts it in the user lib64 directory. So I'm just going to export my LD library path to my current path and then add user lib64 as well. I should probably put that in my bash startup, but I'm going to just do it in my other two terminals just in case we use those terminals a little bit later. Okay, now we should be ready to get rocking here. Let's make a directory called InstructLab. Go into that directory and make the font just a little bit bigger. And let's check our Python version. Make sure we have Python 3.11, and we do. Perfect. So let's do Python 3.11, and let's create a virtual environment here. And then we're going to source that virtual environment. venv bin activate. Okay. Oh, misspelled it. Let's type it correctly here. So now we're inside of our Python virtual environment, and we can begin to install stuff. I always like to, just when I'm on a fresh box like this, just to remove the cache pip directory in case anything got cached from, you know, the OS install or any RPMs being installed. And then we're going to simply do pip install InstructLab, and this is going to pull down the latest version of InstructLab and install it inside of that virtual environment for us. Now this will take a bit of time. Again, Torch here is about 800 megs. Luckily, this box is actually in a public cloud provider, so it should have a really nice internet connection, but it's still going to take a while to like build the wheels and all of that. It's only getting 100 megs a second. I get that on my home fiber. So we'll let this finish. I'll speed up this video so you don't have to watch all of this going. It's not very exciting. Okay, so that was done. What's interesting though is this installed a llama CPP version that does not actually support CUDA, so we want to fix that. So I do a pip cache remove. If we spell it correctly, pip cache remove llama CPP Python, and then we want to pip install and a force reinstall of llama CPP, a specific version of 2.7.9, and we want to set CUDA on, and this will download that CUDA enabled llama CPP for us. Okay, so that's done. We can ignore the error message about NumPy. It'll fix itself. Now that we have llama CPP, what I want to do is install the CUDA version of InstructLab. So pip install InstructLab again with the CUDA stuff. And again, like I said, don't worry. All of these commands will be in the description that you can just follow. Okay. Now comes the fun part. We're actually going to install vllm and a specific version, and this will allow us to have the inferencing engine vllm, which is pretty fantastic. This does take a long time to get installed. Think 10 minutes here, so I'm going to fast forward while this, and I'll see you back when it's done. But let's get that kicked off and get installing. This is the last step. After we get vllm installed, we can actually begin using InstructLab. We'll do some synthetic data generation. We'll look at the new profiles. We'll look at the new Q&A file structure or file information, and we'll do some inferencing, and we'll have some fun. Boom, let's go. Okay, we got vllm now. Next thing we want to do is create a config profile. So I already have one created. Let me get out of full screen here. Let me see, it's been forever since I've been in full screen. So I am going to open up my Git repository here, and I will again put this link in the bottom. I have I just committed I thought I did. Maybe I did a profile, but we want to clone this regardless. So I'm going to copy this and I will clone it onto this local box here. I'm going to make a directory called code, go into code, and I'm going to git clone this directory, and then we'll go into Back to the Future, see what we have there. Okay, so I do need to create a profile. I thought I'd committed one to my repo. I will by the time you watch this video, but I'm going to call this grantprofile.yaml. And because I have this local, I'm just going to copy this. Oh, I updated, but I didn't commit it. I'm going to copy this into my VI session over here. And this is just setting up the arguments for my specific GPUs. This is for the L4s. So I'm going to save that. Again, you can look at it in my Git repo. So now I want to do ilab config init, and I want to pass in a training profile called grant profile. And it's going to ask me for the taxonomy repo. Do I want to clone the basic one? Yes, I do. A path to my model. Let's change this. Yeah, let's just leave that for now. Okay, so now I should have ilab all up and running. Let's do ilab -- version 18.4. Okay, so I should probably go check the README and see what's new in 18.4 from 18.3. But now we can do ilab system info, and we can just look at everything. We can see, look, my CUDA is all there. I got my GPU offload. You can see my NVIDIA cards here, all kinds of good stuff. Okay, so let's look at my config. One of the new commands with the 18 branches, you can also do ilab config edit, and this will allow you to change anything in your config. And so you can see here what it's going to default to for the judge model, which is Prometheus. Different settings in here that you can tweak. Okay, so let's exit that, and now let's copy our taxonomy file. If I go into code and we want to use the Back to the Future example, I'm just going to show this to you real quick if you haven't seen my other videos, but this is basically a question and answer file to teach the model about the flux capacitor and the DeLorean, which enables time travel. You can see the domain is time travel. It's created by myself. What's new in the 18 versions of the code is we can now provide context and then provide 3 question and answers based on that context. So you can see here the context is the DeLorean sports car manufactured by the DeLorean Motor Company 1981 to 1983. Then you can get very specific to set the examples. When was the DeLorean manufactured? Provide the answer. Who manufactured the DeLorean? Etc. So you want 5 contexts, and you want at least 3 Q&A pairs for each context. So 5 contexts, 3 Q&A pairs. Now down at the bottom, just like you're familiar with, you also pass in an outline of the document, the repo for the document, and the file. So if we go back to my repo and look at data, this is the entire document that we're going to be using in the training. Okay? If you're familiar with InstructLab, you should be familiar with this already. Not much has changed there except for the requirement of the context now. So we want to place this Q&A file in our taxonomy. This is also new with 18. The taxonomy is now in the local share InstructLab directory. And there's going to be some different directories here. While I'm here, I might as well tell you what they all mean. Chat logs is going to keep a history of the interactive chats that you have with the model. Checkpoints are things that are going to be saved as you're training, doing synthetic data generation. Data sets are where the knowledge and the skills synthetic data generation are going to be stored. And then taxonomy is the taxonomy as we are used to. So I'm going to go into this taxonomy directory, go into knowledge, and for my domain, you remember I called it time travel. So I'm going to make a directory called time travel, cd into that, and I'm just going to simply copy this Q&A file into this directory. Okay, so let's go back into the InstructLab directory. Now I can do an ilab diff, and it'll validate my taxonomy is valid. I should have done ilab taxonomy diff. And you can see that it did indeed pick up that Q&A and the taxonomy. Okay, so that is pretty great. What we want to do now is actually download what's called a teacher model. And a teacher model is what's used for synthetic data generation to create essentially additional Q&A pairs. Because I am on real hardware here, I want to download a pretty nice teacher model. So I'm going to use the Mixtral model. And I will blur out my Hugging Face token. But this is a pretty good model. It's 24 gigs in size. And we're going to be using the safe tensors for this. And as we're doing synthetic data generation, it's going to serve these safe tensors via vllm. This will give us very high quality synthetic data during the synthetic data generation part of this. So I will let this finish, and I will see you when it is done downloading. All right, we have the Mixtral model downloaded that we're going to use for synthetic data generation. Now I want to download the Prometheus model that we're going to be using for the judge. And this is a much smaller model. It's a 7 billion parameter model. And then finally, after this, I want to download the Granite 7B model. And that's what we're actually going to be training. Okay, that's downloaded. So now I'm going to download the Granite 7B Lab. Notice none of these models are quantized. We're dealing with the unquantized versions of the models and the safe tensor files at this point with InstructLab, and that is simply due to the amount of hardware that I'm using here that I'm able to do this. So now let's generate some synthetic data. Let me clear my screen. And I'm going to paste this in as well, just so you can follow along. And again, all in the description. We're going to do an ilab data generate. And I'm going to pass in the model that we're going to use for the synthetic data generation. And that is the Mixtral model that we just downloaded. I'm going to pass in 4 GPUs. And we're going to run the full pipeline here, which is pretty phenomenal. Then we're going to put this in the background. And down here in the bottom right, you should see these GPUs finally spin up. So let's see what happens here. Ooh, there we go. They're spinning up. Okay, so we're back. This is going to go for a little bit. And we should see the output of this. So let's tell our nohup.out file and we can see what's going on. Okay, so we're waiting for the vllm server to come up right now. Man, look at this. Our memory is getting used. Our GPUs are getting hammered. vllm is getting ready to come up. We're just waiting for it as it's loading those models. Or sorry, the safe tensors of Mixtral in the memory. And then the synthetic data generation will start up. There we go. Pretty exciting. Woo, dog. Look at this. This is awesome. I feel like I'm in NASA Command Center at this point. I'm super excited about this. After this runs, I'll show you the output, and we can see some of the synthetic data generation that was created. And then we will actually train the model. We'll get that started, and then we'll go from there. Look at this. Those GPUs are running 93%. Woo! Love it. All right. We can see our GPUs spinning down here. We can see that the generation took 432 seconds. Not bad. Okay. So now I want to show you, if we go back, excuse me, into the home directory and go into .local share and go into InstructLab, I want to show you where the new synthetic data generation spot is. Go into data sets, you will see we have these knowledge train JSON lines file. This is where the synthetic data is. So let's just take a look at that real quick. And you can go through and look at all of the synthetic data that was created. How many lines were there? 117. All right. So let's go back to our InstructLab directory, and now let's train the model. Let's do ilab train. It's ilab model train. And if you do -- help, you can look at all the new options that are available now. You can do multi-phase training. You can do all kinds of cool stuff now. So let's do ilab model train. I'll show you a simple example of this. And the first thing we want to pass is the model path of what we want to train, and that is going to be InstructLab /granite-7b-lab. And then the data path is where our synthetic data is, the ones that we just looked at. So that is in my home directory in the .local share InstructLab data sets, and then it was called knowledge. What was it called? Knowledge train. And then we simply just hit enter here, and we should see it begin training the Granite 7B lab model with the new synthetic data. Oh, I must have passed in. Oh, I need the. I didn't spell granite correctly. I did Grant. Now, everyone knows that my name is Grant, so I make that typo all the time. So let's fix granite now and see if this actually works to where we begin training. There we go. All right. So this is going to train the model. So we'll let this run. We should see our GPUs start getting hammered again here in just a second once everything gets going. So I'll see you back when this is finished. Yes, indeed. I might even have to break out the old trusty fedora for the first time ever for that one. All right, so training is complete. We did 4 epochs. That's the default. If you want to run more epochs, you can certainly pass that in. But now you can see where the models have been saved to, and it saves them at different checkpoints into the home instruct.local share InstructLab checkpoints, Hugging Face format, samples 544 was the last one. Now, obviously at this point, you would want to do maybe an evaluation on the different models at the various checkpoints to see, how the training went, but just due to the interest in time, I'm just going to serve one of these models up and then we will chat with it. So let's do ilab model serve, and again, you can always do -- help, and you can see all of the different arguments that you want to pass in, or that you can pass in. For this one, we want to pass in model path and GPUs. So we'll do -- model path, and it was in the .local share InstructLab checkpoints directories, and you can see in the Hugging Face format the different checkpoints that were saved. Let's just pick one. Now, obviously, you wouldn't do this. You would evaluate the models, but it does take time to do that. So let's just serve this one. Oh, I forgot to pass in GPUs. Let me kill this real quick and pass in -- GPUs is 4. Otherwise, the inferencing would be a bit slower. And I do want to chat with this model and see how it performs. So you'll notice if I pass in a directory with safe tensors, it's going to understand that it needs to start vllm. If I passed in a gguf file, it would serve it with llama CPP by default. So it is loading the safe tensors of that model into my GPU memory as seen here. And now we have vllm running. So let me make this a little bigger, and we'll do our ilab chat down here. One of the other things you can do before we do ilab chat is you can do ilab. I gotta source my environment here. Source venv bin activate. You can do ilab model list. This will show you all the models that you have downloaded. If you do ilab chat -m, it will tell you. Or just ilab chat, it'll say that model is not, maybe it did work. Okay, great. So I am chatting with samples 554, And I can say, please tell me about the DeLorean DMC-12, which is what we trained it on. And you can see it was, goodness. It did a really good. Look at this. Let me just kill this so I can scroll up. We can see, I just want to go through this so you can see the kind of the quality that you're getting now on real hardware using the mixtral synthetic data generation, unquantized models. It was created by the DeLorean Motor Company in 1981, 1983. It does indeed feature gull-wing doors. I know more about a DeLorean than I should. And I believe I saw something about the flux capacitor in here. Yes, indeed. I was smart enough to know that it was fitted for time travel. And then, look at that. Flux capacitor costs $10 million to repair. And it even gives me a maintenance schedule. This is pretty awesome. Okay, so let's go ahead and, excuse me, exit out of this. Just a fun, quick little video. I know getting started with InstructLab on, expensive or enterprise class hardware using non-quantized models is a little overwhelming for some people. So I thought I would just create this video to give you the steps that I use to actually spin all this up and do, model alignment and synthetic data generation using the mixtral model, again, unquantized to get the highest fidelity possible. But I hope you enjoyed this video, and I look forward to seeing you in the InstructLab community. Remember, one command, pip install InstructLab. See y'all later. Bye.